as what we have computed earlier in nuclear fission, 200 mega electron volts is being um, created to form these daughter nuclei. So these 200 mega electron volts of binding energy, or we should say the increase of 200 mega electron volts of binding energy, should correspond to some decrease in some amount. And we know that from the equation E equals mc squared, this 200 mega electron volts of energy is equivalent to some form of mass multiplied by c squared. So this suggests that mass is being lost. So we should, by conservation of energy, some amount of mass must be lost in the process, because you cannot just have immediately have created 200 mega electron volts of energy during the fission process. So mass must be released during the process, and that mass is converted to kinetic energy of the daughter nuclei. Or in other words, this is the energy released. This is the energy released in fission. So 200 MeV, as initially computed, is the binding energy, and it is also approximately the value, which is the energy released by splitting a uranium-236 nucleus. So upon the process of splitting uranium-236, krypton together with barium and 3 nuclei is produced. So this causes a chain reaction to the other uranium-236 nuclei. So the release of one neutron is used as another bombardment to another nuclei, and the other neutron will bombard another uranium nuclei. And similarly, this process repeats until all the uranium nuclei is consumed. So normally, if you want to create a large amount of energy, you can just leave the process as releasing 3 nuclei in fission. So this releases a very high amount of energy, and this is the principle behind atomic bombs. So this chain reaction is uncontrolled, and this releases a very tremendous amount of energy. So if you want to control this kind of nuclear fission, you would want to remove the two neutrons, or to absorb the 2 neutrons being released in the process. So if you remove 2 neutrons, only 1 neutron will be bombarding another uranium nuclei, and similarly it causes a chain reaction wherein only 1 neutron instead of 3 neutrons is bombarding nuclei. So in this manner, you can control the energy release, and this is how nuclear fission works in power plants. So they don't want to release all of the energy, or they don't want to release or to consume all of the uranium nuclei in just one reaction. So this is a slower process compared to the release of energy in an atomic bomb.